Welcome back to another episode of Math with Miss Murthy. Today's lesson is lesson 9.2. We're looking at surface area of rectangular prisms. Okay. As usual, pause and do the warm-up on your own, and I'll also share the standards for mathematical content and practices. So pause this on your own to read them through. Right. Today's goal is to make nets and find surface area of rectangular prisms. Now, what is a net? A net is nothing but the two-dimensional representation of a 3D figure. So when you construct a net, you're basically deconstructing the 3D figure into its 2D faces. Now, you can see, and I'll share another video which will go through how you could deconstruct these. But basically what we are doing is we are deconstructing the 3D figures at its edges. Okay, it's like taking a box, literally, and slicing it along its edges to open it up. And then we see how it's going to open up. Okay. Now we know that a rectangular prism has 6 faces. Okay. This right here is going to be our bottom face. And this is our top face. Okay. Now each set of faces, there are basically 3 sets of congruent faces. Like the top and bottom, the dimensions are identical. Okay, so they are congruent faces. And then you could call, let's see, which one are they calling? This over here is the front. This face is my back face. Okay. And when I say this face is the back face, what I mean is this face, okay? That's my back face. And then this face over here is going to be one side. And then the similar face over there is going to be the other side. And you'll see how this deconstructs in a moment. So we have 3 sets of congruent faces, okay? And this is pretend that you're opening the box up, right? So we have the bottom stays the same, okay? I'm gonna go over this. The bottom stays the same, right? And then if you look at this flap, if you were to fold this upwards, right, that becomes your front. You fold this back upwards, that's going to become your back, right? You fold this over this way, that gives you one side. You fold this side over this way, that gives you the other side. When you fold this side over, right, side 2 over, the top side which is attached to it is going to come over, and then it's going to go over the very top. Okay. So what similarities do you notice between the length, width, and height of the prism and the dimensions given in the net? And before we proceed on much further, this is on page 495 of your textbook. Okay. Now you can see that let's see the dimensions given in the net. If you look at this, because the bottom face has these 2 dimensions, 4 inches and 4 inches. Whoops. Sorry. You can see that this dimension and this dimension, which are given for the bottom, are going to be these 2 dimensions. These 2 dimensions of the net, right? So each set of dimensions is going to have the corresponding dimension in the net, and therefore there are 3 sets of dimensions for each of the congruent sets of sides. All right, let's move on. Let's take a look at example 1. This example is on page 496 of your textbook. First, we're going to only make nets. We are not looking yet at how to calculate the surface area of nets. Okay. We have a right rectangular prism which has a length of 10 centimeters, a width of 6 centimeters, and a height of 8 centimeters. We're going to draw and label a net to represent the right rectangular prism. Think about how the prism can be unfolded to make a two-dimensional net. Is there only one way to do this, or are there multiple ways? Right. Now, I'm going to copy this over and bring this over to my next page so that I could use it. Make this a little bit smaller. Okay. Now, what I'm going to do is, and then I'm not doing this on a grid paper in your textbook. You'll see that this is on a grid paper, right? I'm going to start off with my front face. Okay. My front face has dimensions. Let me move this over a little. Whoops. Okay. Going back to this. My front face is going to have, what are the dimensions? The length, which is 10 centimeter, and the height, which is 8 centimeter, right? And then if I open up the flaps to the two sides, right? This edge is common. Okay, let me show this in another color. This edge is common between the front and the side. Okay, and that's going to be this edge over here. Right? So now this edge, when I open it up, the height is going to be the same, 8. But if you see, this side has a dimension of 6 centimeters. Now, when I open the other side up, right, that's going to be having this common edge, which goes over here. Now, what's the dimension of that side, right? The height, again, is the same, 8 centimeter. And you would see that the width of that side is also the same as the width of this side, which is 6 centimeter. So I'm going to erase a little bit of this to make sure that the dimensions are similar. Now, if you were to draw this on a graph paper, it's a lot easier. Okay. Now, once I have this dimension, right, what's the next step I'm going to do? I'm going to draw the top edge. Now, the top edge is going to have this common, which goes over here, right? And I open that up. Now, what is this dimension going to be? That side is nothing but, if I were to take a look at it, it's going to be the same as this edge, which is nothing but 6 centimeters, right? And similarly, I'm going to open the bottom up. Let's say I open it up along this front face, right? And my bottom edge is going to be nothing but, again, let me denote this with, say, a different color, right? This edge, that's going to be this edge, right? Again, what's the dimension? What is the other dimension? The other dimension for that bottom side is going to be this 6 centimeters. Now I have 5 faces over here. Where's my 6th face? What is it going to be attached to, right? There are multiple faces that you could attach it to. And let's show it, right? One is it could be attached to this side, which is nothing but this side. Or it could potentially be attached to this side, which would be this side. Or it could be attached to this top edge, which would go beyond here, right? Or could it be attached to something else? Well, it could be attached to this bottom side, right? In which case it would go here. So pick any one of these sides. For example, I could just say that I'm going to use it. I'm going to represent it along, whoops. I'm just going to say I'm going to represent it along this side, right? What is my other dimension going to be? I can see that this is 8 centimeter. So it's going to represent this dimension, which would therefore be 10 centimeter in width. Okay, I know this is slow going, but I want you to understand this really well. Okay, so there you go. That's my net. So that right there, I've done draw and label a net to represent the right rectangular prism. I'm going to label it with the dimensions. Okay, now again, let's label it with the what faces are being represented, right? This is my, oops, hold on. This is my front. I can say this is the left side. This is the right side, right? This is going to be the back. This over here will be the top. And this is the bottom, right? And then you label each side. This is 6 centimeters. This is going to be 10 centimeters. And then this over here is, again, this is 10 centimeter. This dimension is 10 centimeter. Okay, now, oh, we finished that. And this just goes through those same steps again, okay? Now, explain why there are only 3 measurements for a right rectangular prism, with each face using 2 or 3 measurements. Well, because the prism only has 3 dimensions. Its length, width, and height. And each face is 2-dimensional. So the prism only has 3 measurements, and each face is going to use 2 of those 3 measurements. Okay, I want you to pause this right here. Do this check problem on your own, okay? All right, let's look at example 1. This example is on page, let's see. What page is this in your book? This is not really example 1. Oh, this is the solution to the check problem. My bad. All right, so let's look at the surface area of a right rectangular prism. The surface area of the right rectangular prism is the sum of the area of all the faces, right? So using a net helps us deconstruct the prism into 2D shapes so that we can find the area of each face, right? Let's look at this right rectangular prism. This is in your textbook, this is on page 498, right? I have this right rectangular prism. This is deconstructed into this net that you can see on the left-hand side, right? Now the length L of the right rectangular prism is 3 inches. The width is 2 inches. The height is 4 inches. So how am I going to go about this, right? Now, as I said before, there are 3 sets of congruent faces. Well, let's see. All right, this says the student measured the top and bottom, front and back, and side 1 and side 2. What shortcut can you use when finding the surface area of the rectangular prism? Right? Again, what is it that you can do? Like I said, we have 3 sets of congruent faces, right? Which are my congruent faces? Set 1 is the front and back. Set 2 are the left and right sides. And set 3 is my top and bottom. My total surface area is the sum of all of these, right? So I could find 6 of these dimensions and 6 of these areas and add them all up. Or I can find surface area 1, 2, and 3, add it up, and then multiply it by 2. So that's going to be my shortcut. All right. So let's take a look at this, right? I'm going to copy this over. Bring this back down here. Whoops. I guess I have to erase my markings over here to be able to copy this. There we go. Right, now let's take a look at it. Step 1, I'm going to find the area of the front and back. Again, surface area equals length times height, or length times width. In this case, because it's the front, I'm going to go with length and height. I can tell my length is 3 inches, my width is 2 inches, my height is 4 inches. So in this case, area of the front and back, each of these, right, this is not together, each of these areas right now is length, which is 3, times height, which is 4, which is 12 square inches. So total area of front and back, I'm just going to say front plus back, equal to 12 times 2, which is 24 square inches. My second step that I'm going to do is area of top and bottom. So I'm going to look at the top and bottom. Again, I know area is, for the top and bottom, length times width, right? That is nothing but 3 times 2, which is 6 square inches. So I can say area of top plus bottom is 6 times 2, which is equal to 12 square inches, right? And then my third set that I'm going to do is left and right sides, right? Area in this case, because it's this side that I'm talking about, is going to be width times height, which is nothing but 2 times 4, which is 8 square inches. So area of left plus right is 8 times 2, 16 square inches. And now when I do my total area, total surface area, is going to be equal to area of front and back plus area of top and bottom plus area of left and right, because I've already added the sets of congruent sides, right? This is going to be 24 plus 12 plus 16, which gives me 52 square inches. Let's see if this matches with what they've given in the book. There you go. That's 52 square inches, right? All right, moving on. Surface area of the rectangular prism. Now, what is a real life example of when you might use surface area? Before we go there, let's see, what is our trivia of the day? There is only one state in the US that borders only one other state, right? There's only one state in the US which borders, I'm not going to go with that. The most expensive home in the world is guess what? The Buckingham Palace. That's our trivia of the day. All right, what's a real life example of where you might use a surface area? Well, you might use it when you have to cover the face of a gift box with wrapping paper, or maybe you have to paint something. Those are some examples of area. So look, we're going to look at example 2. This is an example of the surface area of a rectangular prism, right? So our box has given dimensions of 10, 6, and 8. And you can see here that they've given you the net for this box, or have they? In the textbook, actually in the textbook, they don't start off with the net, okay? In the textbook, you have to come up with a net, use the net to determine the minimum amount of wrapping paper, right? So again, when you open it up, this is going to be your net for this, and we are going to look at each of these sections. So before we go there, how many different sized faces are there? How many different sized faces? Remember, congruent faces are not different sized. So there are 3 different sized faces, right? And we're going to use that to our advantage. That's why we do the congruent sides together, right? So again, just as usual, we're going to do, let's call this the front, the side, this is my top, right? So I'm going to be looking at in fact, I'm just going to go quick here. I'm not going to solve this on my own. The solution is given there. So I'm just going to walk you through the solution. Again, we can see that the front and back faces are congruent. We find the area of 1 and we're going to multiply that by 2, right? So my area of the front is length times height, which would be this length times this height, right? So that's 10 times 8, 80. So the front plus back together is 2 times 80, which is 160 square centimeters. Okay. Again, when we go, the top and bottom are congruent. So we find the area of 1 multiplied by 2. The area of the top and bottom is length times width, which is 10 times 6, gives me 60. So the combined area of top and bottom is 2 times 60, or 120 square centimeters. For the sides, again, the two sides are congruent. So area of the side is width times height, which is 6 times 8, which is 48. So a sum total of the area of both sides together is 2 times 48, which is 96 square inches. And then for the surface area, we're going to add all of this. And that gives us a minimum of 376 square centimeters. Okay. All right. So why is the unit of the measure in this case square centimeters rather than centimeters or cubic centimeters? Well, because we're not talking about a single dimension, right? If it's a single dimension, such as a length or a width, it would be a centimeter. Cubic centimeter is only going to come in when we're talking about volume. Surface area only concerns with 2 dimensions, and therefore we use a square centimeter and not a cubic centimeter. Okay. So, all right, pause and do this check problem on your own, and I'm going to move on. Okay, here's your solution. Now, let's look at this applied problem, right? Now, this is not just the surface area. You have to think about the question clearly. Takeru is planning to paint the walls of his bedroom, which is the shape of a rectangular prism. The bedroom has 1 window and 2 doors. The dimensions of the windows and doors are shown. And you're told if 1 gallon of paint covers about 150 square feet, how many gallons are needed to cover the walls of a room that is 20 feet long, 15 feet wide, and 8 feet high, right? Now, before we do this, I'm going to copy this part, right? Copy this, paste this here. And then the other piece of information that I need is going to be from here. I'm going to paste that here, okay? These are the 2 pieces of information I need. So let me draw this out, right? Let me draw this out. Right? This is my room, right? It has a ceiling, it has a floor. I'm going to be looking at, let's see, did they say how many? 1 window and 2 doors, okay? Let's say my 2 doors, one is on this side. Let's say the other is on that side. And let's say my window is over here on this side. As far as where I'm painting is concerned, okay, now how do I look at how much paint I'm going to need, right? Let me label the sides that are going to need the paint. Again, the front side, right? This side, left, I'm just going to call it my left side, which is side 2. This back side, okay, side 3. And then this face, right? That's side 4. Now my question is, why am I not talking about the ceiling or the floor, right? In this case, the floor might be a different material, so you don't need to paint it. How about the ceiling? Usually sometimes ceilings might have popcorn ceiling or it has a different texture. So that's why we're not including the ceiling, okay? So in this case, we're going to be looking at calculating the 4 walls. So you have to keep in mind, now we're not doing the entire surface of the rectangular prism. Yeah. So let's look at the phases, right? Phase 1 and phase 3. So for the walls, I have 4 walls. The question also clearly tells you only the walls. The question does not include the ceiling or the floor, right? For the four walls, first set, I can say front and back, right? My second set is left and right side. Okay. Now, area of, let's say, area of front is nothing but, again, let's see. This is 20 feet long, 15 feet wide, and 8 feet high, right? So my front and back are going to use the dimensions 20 and 8, right? That's equal to length times height, which is 20 times 8, that's 160. So area of front plus back is equal to 160 times 2, which is 320 square feet, right? Now my step 2, area of side walls. That is going to be equal to my width times height, right? Which is nothing but 15 times 8, which is 120 square feet, right? So area of walls. Now, again, keep in mind, what is it that we are looking at? Step 3. Area wall. Okay, the one thing that I forgot in this step is area of left plus right is going to be 120 times 2, which is 240 square feet. Now, going back to this, I'm going to do step 3 here. Area of walls is equal to area of front plus back plus area of left plus right minus, remember, you're not painting the doors or the windows, right? 2 times area of doors, or I could actually say minus area of 2 doors and minus area of window. Okay. Now, what is the area of the doors? I'm just going to add on. Let me calculate that here actually. Area of door is 6 3/4 times 2 3/4. If I were to write this as an improper fraction, that's what 27 by 4 times 8 plus 3, 11 by 4, which is nothing but, I'm going to actually convert it into decimals over here, 6.75 times 2.75, which gives me 18.5625 square feet. So I can say area of 2 doors is equal to 2 times area of door, which is 2 times 18.5625, which is equal to 37.125 square feet. And I can say area of window equals 3 times 5, which is 15 square feet. So I'm going to use this now, right? Going back to my equation, area of front plus back is 320. Area of left plus right is 240 minus 2 times area of door, 37.125 minus area of window, which was 15. So this is nothing but, let's see, 320 plus 240 is 560 minus 37.125 minus 15, which is 509.875 square feet, right? And now on to my last step, which is step 4. Again, I know I'm doing this all over the place because there's not enough space, but again, look at how I'm labeling the steps, right? This is step 1, step 2, step 3, step 4. Last is 1 gallon of paint covers 150 square feet, right? How many gallons do we need to cover 509 square feet? So I know 1 gallon covers 150 square feet. Therefore, 2 gallon covers 300 square feet. 3 gallon covers 450, which is still less than the amount that we need to cover. 4 gallon is going to cover 600 square feet, which is more than the area we need to cover. Therefore, I can say we need 4 gallons paint to cover the walls. Okay. All right, I know this is ending up being a long video, but that's because I'm working through each step. All right, I want you to pause this right here, work on this check problem on your own. And here's the solution, 144 square feet. All right, guys, that's it for today. I will post the exit ticket up on Google, on the Google form. Okay, see you tomorrow. Ciao.